Okie dokes. So what we're going to take a look at in this video is we're going to take a look at how we can measure the total resistance of combinations of resistors, so several resistors at the same time. So the three scenarios we're going to look at two resistors in series, what is their net effect of having two. We're going to do two resistors in parallel, like this. And then we're going to do a situation where we have two in parallel, but then there's also this one over here. And we're going to look at what happens to the total resistance in each of those three. So the way we're actually going to do that is we're going to build a circuit like this. So we've got our power source in there. We've got our ammeter that's measuring the current that's going through the battery. And we've got a voltmeter measuring the potential difference that's being supplied to all of the resistors by our battery as well. And essentially what that will figure out is what is the total resistance in here for each of our combinations. So that's the idea. So let's start off with. So I'm going to build a series one to start off with. So let's take a look at the equipment there. So what we've got is I've got four different resistors that I've already measured the resistance of. And then I've got an ammeter with a shunt, and we've got a voltmeter here. So I'm going to put two series resistors in here. So the ones I'm picking, so I've got a 9.5 ohm resistor. This is just whatever I happen to find in the lab. And let's pick, and we've got a 4.1 ohm resistor as well. Okay, so we've got it set up. So I plugged the ammeter on the 5 amp setting. Again, I want to make sure it's safe and we're not going to get too big a current and blow our ammeter. So I'm going to plug the voltmeter from one side of the series resistors all the way to the other side here. So we're measuring the potential difference across both of these two resistors, and we're measuring the current going through all of the resistors as well. Okay, so let's take a look at our readings. So on here, looking at that, our current is less than half an amp. So I can switch down onto the more sensitive setting, which is nice. So we've got a current of, that's 4.4 on the, what's that? 4.4 on the scale, so that's 0.44. So I'm just going to quickly record. So we get I is 0.44 amps once I've remembered to convert it, because we remember we have to divide by 10. Potential difference is 4.92 volts. So that means we've got a total resistance by, if we divide that, so 4.92 divided by 0.44 gives us 11 ohms. Now the two resistors we used one that's about 4 ohms, and we used one that's about 9 ohms. So we'd expect a resistance about 13, give or take. But actually that's not what we've ended up with, but it's not too far away. But this is how we'd measure the resistance here. So let's now look at our parallel one. So I'm going to use the same two resistors, but I'm now going to put them in parallel into this gap here. So let's unplug them. So what we need to do is I'm just going to plug one resistor in between the two. And then to put something in parallel, we just connect wires to each end. So if I hold this up, you can see that one wire goes in this end here, one wire goes in that end there. So we've now got those two in parallel with one another. So again, it's the 4 ohm and the 9 ohm resistor there. So let's have a look at what we've got. So our current is, I'll put it down so it's not shifting. Our current is, we've gone up here. So we've got a current of 1.6 amps. 6 amps. So I have changed the setting, so it's gone up to the 5 amp again because it went off the top of the scale. Potential difference is 3.64 volts, giving us a total resistance of, let's do 3.64 divided by 1.6. So we've got 2.3 ohms. So you can see that even though each of these resistors is bigger than that, so this is a 4 and this one is a 9, we've actually ended up with a total resistance of 2.3 ohms. So actually adding resistors in parallel decreases the total resistance here. And we actually will come across an equation that will allow us to predict exactly what the total resistance should be, but we'll get to that in a second. So the final one we're going to do is this one, where we've got like a series and parallel. So I'm going to chuck one more resistor in at this stage. So I've got an 8.5 ohm resistor as well. So I've already got all of these in parallel. So let's not mess with that too much. Okay, so those are currently connected in parallel. So I'm just going to put the resistor into here. Okay, so what we've got in here is I've actually done it the other way around. So I've put the 1 over here and then the 2 over here. But if you can see that, so we've got current comes around here, goes through here, then it will either go through here or it goes round the top in here. So we've created the configuration that we've got on the diagram, just the symmetrical opposite. So I've got the 8.5 ohm by itself, and then I've still got the 4 ohm and the 9 ohm in parallel. So let's measure our current and our potential difference to calculate our resistance. Potential difference is 4.77 volts. Current is less than 1 amp, so let's go down to the more sensitive setting. So that's 0.52 amps on there, giving us a resistance of 9.2 ohms overall. So you can see we could have actually just done all of this exact same thing with just the 9 ohm resistor. This circuit, as far as the battery is concerned, is identical to having just one with a 9 ohm resistor effectively. Interesting. Okay, so that's how we can measure the resistance of different configurations of resistors and figure out what their total resistance is. And I'll just show you my results table up on here so we can see what we've got. So you can see in our first circuit here, adding resistors in series, you can see gives us a bigger overall resistance. That's actually a little bit smaller than I'd expect. I'd expect something up more near 13 ohms, but we've got the right idea. You can see in parallel, we can see adding them in parallel creates a total resistance that's lower than either of the individual resistors is. And see where we've got a combination of series and parallel, if you like. So these two we know has a resistance of 2.3 ohms, which we then add on to 8.5. You would expect a total resistance about 10. So 9.2 ohms makes a lot of sense in there. These experiments somewhat matches with what we'd expect theoretically there.